Okay, guys. Okay, thank you for the first Cempaka A-level activity. Okay, today I will talk about mathematics and the Enigma machine. Okay, for those who haven't entered the group yet, you actually can enter the group. Okay, for further discussion. Okay, so without further ado, I will continue with the explanation. Okay. So today we talk about the mathematics of Enigma machine. Okay, for your information, the material is actually not owned by me. Okay, so I actually learned it from the University of Waterloo as well. Okay, so let me introduce myself for those who still don't know about me. Okay, my name is Samuel Locke. I'm a teacher from the Cempaka A-level. I'm teaching mathematics as well as further mathematics. I've been teaching for 16 years. Okay, my degree is Bachelor of Science Mathematics in University Malaya, my Master of Applied Statistics and Master of Mathematics for Teacher from University of Waterloo, Canada. Okay, so for those who know about this story, do you know about this movie, the Imitation Game? Okay, the Imitation Game. So this movie is talking about how Alan Turing actually built the first computer in the world and helped the Alliance to win the World War II. Okay, so in the movie, there are still a little bit of the entertainment elements inside the movie, but for those who are really want to know more about the history, you can actually read more online. Okay, try to Google it. So first of all, let me tell you what is cryptography. So cryptography is the art and science of actually changing a message into something unreadable. Okay, changing. So you have a readable message. Okay, you go through some form of cryptographic method. Okay, the ciphering method. You change it into something unreadable. Okay, then the person who actually receive your unreadable message, he or she will need to know your technique and actually change it back into something readable. So the process of changing readable into unreadable is called encryption. The process of changing unreadable back to readable is called decryption. Okay, there are many different cipher techniques available, okay, throughout the human history. As you can see from here, the very first ciphering technique that appear in the history is called Caesar cipher. Okay, it's actually named after Caesar the Great. Okay, so in his book, it's mentioned about how he actually changed his message into something else so that it was not detected by his enemy. Okay, so Caesar cipher is actually a type of substitution cipher. Okay, what exactly is substitution cipher? From the letter that you want to write, you actually can change it into something else. Okay, you can actually change it into something else. So you have A change to Z, B change to Y, C change to X, D change to W, E change to V, or F change to U. Okay, so this is just one of the one possible substitution, because as you can see from here, I write A to Z and I Z right back in the reverse order back to A. Okay, and it's not necessary that I must reverse the order. Maybe I just switch the three letters to the left also can, or three letters to the right. So you can actually change the letter accordingly. So with this method, let's say I want to encrypt a message dot dog, D here, O here, and the G here. Let's say I want to encrypt this message dog. So D, okay, I will change it into W. Okay, then O will change to L, and the G change it to T. The person who receives your message will be received as W, L, and T. Okay, will be received as W, L, and T. So whoever receives your message will need to know how to what is your algorithm, and only he will able to exchange it back to dog. Okay, another example of the ciphering technique is called transposition cipher. Okay, let's say I have a message, meet me for lunch. Okay, Stan, that's Stan. So meet me for lunch. So I arranged this letter into a 5 by 5 boxes. Okay, MEET space ME space FOR space LUNCH space dash space STAN space. Okay, so when I rewrite, encrypt the message, maybe I want to rearrange them into a different position. Maybe I write from bottom to top. So I write SCRMM TH space EE A space L space E. Okay, N dash UFT space NO. So whoever intercept your message will be like wonder, hey, what is this message? Okay, how do I actually read this? So you will need to actually put them back into a boxes, and only you know, hey, oh, this is the letter actually write like this. Okay, so this is another example of the ciphering method. So what about this Enigma thing? Okay, it's all back to World War One. Okay, World War One, the Germans actually lost their war. Okay, and after World War One, Winston Churchill actually wrote in his book and mentioned that they managed to win the war because they managed to intercept the Germans' message and intercept their message. Okay, and encrypt their message. Okay, so only after the war, okay, German realized that, hey, the UK managed to encrypt their message, though they was like quite angry, okay, and say, okay, the next time they will not, they will make sure their enemy will not able to encrypt their message. So this is some of the message, the technique they actually apply. And at that time, you can see that the wheel, you actually can turn the wheel here to actually map with the alphabet that you want to use. Or you can actually use code book, where we need to refer to the code book, then only you can encrypt the message. Okay, after World War One, they are from the mechanical way of encrypt message. Okay, then they develop to the electronic way. Okay, the mechanical rotor like this. Okay, so there is a pad and tab form the pin and plug cipher. Okay, so one of the most important one will be the Enigma. Okay, the Enigma actually is a combination of mechanical and electronic. Okay, so they actually change your electronic impulse in go through the mechanism and actually come out with the message. Okay, so this is the Enigma machine. This is the famous Enigma machine. Okay, so you can see here in front here there's a light plug board. Okay, this is a plug board here. Okay, this is a key pad or keyboard. You can actually tap the keyboard. Okay, this is a light bulb. Okay, this part here is actually the cover. You actually can lift it up, cover. Okay, so from inside the cover you can see 3 rotor. Okay, 3 wheel here. These 3 rotor actually take it out. Okay, and you can arrange them in any order that you like. Okay, so let's more about this Enigma. The Enigma is actually bought over by the German Navy. Okay, this information was not owned by me. You can actually read more from the Cipher Museum. Okay, from the Cipher Museum. Okay, then Hugo Coach actually developed the rotor. Okay, then after that the German add in additional feature inside the Enigma machine that actually make the Enigma machine much more complicated. Okay, so I'm not a historian. Okay, you can actually read more on if you are interested in the history. Okay, or if you are interested on the spy story, you actually can look on that, how they actually get the Enigma machine, how they actually send spy to actually discover the codes and so on. Okay, okay, for me, I will talk more about the mathematics about it. Okay, the mathematics of the Enigma machine itself. Okay, so as you can see, this is a typewriter. Okay, so two combination of electric and mechanical. Okay, there are cables here. Okay, there are light bulb here. Okay, there are the 3 rotors, and at the back there is a reflector. Okay, so this is a keyboard. So the keyboard is the same as what we have. This same as what we have here. Okay, today. Okay, no changes at all. This is the plug board. Okay, the plug board is the additional feature that added by the Germans. Okay, they actually increase the complexity of the Enigma machine. The plug board has a 26 hole with the 13 cable. Okay, the 13 cable actually connected any two letter. Okay, any two letter. You can use any you can use 0 cable, okay, if you want, or you can use up to 13 cables. Okay, because you only have 26 letters. Okay, each cable will actually connect 2 letters. You have the rotors. Okay, the rotors, you have a 1 to 26 here. Okay, so there are cable inside. Okay, the copper cable inside that actually connect changing of the position of the 2 letters. Okay, then there are 3 rotors here. As you can see, these 3 rotors are actually from the 5 available. Okay, from the 5 available. Then you can actually take out the 3 rotors, can actually rearrange for any order that you like. Okay, for those who have learned S1 statistic 1 permutation and combination topic, you should aware that this is a 5P3. Okay, equations. Okay, so 5 times 4 times 3 have become a 60 possible position. Then inside the 3 rotors, okay, there are 26 letters. So each time, so when the electric pulse sent through the rotor, okay, it will change and pass through the first rotor, then go to the second rotor, go to the third rotor. Okay, so what actually happened is when you press the button, okay, on the keyboard, when you press the button, the rotor will lift up by 1. Okay, if you press the button for second time, the rotor will rotate another time. Okay, rotate another time. So therefore, because of every time that it actually been rotated, okay, every time it has been rotated, so it can be a 26 order here and another 26 order here. It can be have another 26 order here. Therefore, you have a 26 power of 3. Okay, of 3 different setting. Okay, you actually can change the setting in any order that you like. Okay, let's say maybe today we want to set it as AAA. Okay, or maybe we want to set it as DOG. Okay, that will be your initial setting. Okay, that will be your initial setting. Then at the back you have a reflector. Okay, after the electronic pulse sent through the 3 rotors, it will go to the reflector. The reflector will reflect the pulse, go through the 3 rotors again, then only appear on the light bulb. Okay, so this is how the reflector works. Okay, and the light bulb, okay, this is on the cover. This is on the cover. So is once you press the button, then the light will light up here. So maybe A goes to T, so the T will be light. So what exactly is the mechanism of the Enigma machine? Okay, so if you press the button A, you'll go to the plug board. This is the plug board. Then go to the first rotor, the second rotor, and the third rotor. So the letter JLZ here is just representing the setting. Okay, just representing the setting. As I said earlier, you can set the setting as AAA, you can set the setting as something else. Okay, so this is there are many different settings. Then it passes through the reflector. Okay, come out with the third rotor, come out the second rotor, come out with the first rotor, then pass by the plug board, then only light up. Okay, then only will light up. So A will go through this journey, then comes to K. Okay, the Enigma mechanism, as I said earlier, after you set this setting, once you press the letter A, okay, you press the button A, the rotor will lift up by 1. So as you can see, the wiring inside all changes. Okay, wiring changes. Then if you press the button for the second time, the keyboard for the second time, then you rotate once again. Then another round that you actually change the order of the table. Okay, so this is actually what happened. So theoretically, how many possible maximum setting that available by the Enigma? Okay, calculated that it can have up to 3 times 10 power of 114. Okay, scientist says number of atoms in the observable world is only 10 up to the 80. Okay, this will actually much more than the number of atoms in the universe. Okay. So since Enigma machines is so complex, how did the Alliance manage to win the war? Okay, they win the war is not because of the Enigma itself. Okay, it is because it is not because that they managed to crack the Enigma. Okay, it's because of the procedure, a flaw in during the procedure. Okay, let's try to look through the procedure. Okay, so every day they will have a daily key. This daily key is inside their code book. Okay, this is inside their code book. So before the submarine, the German submarine actually went out for their mission. Okay, the German submarine is called U-boats. So they will receive their code book. Okay, they will follow the code book to actually set up their daily keys. Okay, but this daily keys is not used to encrypt or decrypt the message, because once the code book actually fall on the enemy hands, it will be useless anymore. Yeah. So therefore this code book is for them to receive a new key. Okay, receive a new key, and this new key will be specify the position of the 3 rotors position. Okay, and it will stand up twice. Okay, because of this stand up twice, they with the help of mathematics together with the first computer in the world, okay, they managed to reduce the possibilities, okay, and had ended in the end managed to decrypt the message. Okay, so therefore the Enigma machine, the setting of the Enigma machine is actually really complex, but they managed to win the war is because of the procedure here. Okay, so how do they actually get the code book, how they actually get the key and so on? There are some spy stories actually behind this World War II. For those who are interested, you actually can look through the more on that. Okay, so okay, as I said initially, the Enigma machine was they don't have a plugboard. They don't have a plugboard, so they only have the rotor and the keyboard. Okay, they only have the rotor and the keyboard. Then after that, there only they add in the plugboard, so which is there in front. That okay. Notice anything unusual about this Enigma? Okay, so these are the plugboards was covered. Okay, as you can see, it's covered. Okay, the even German's alliance, okay, Italy or Japan, they received the Enigma machine without the plugboard. Okay, so from at the initial stage of the war, okay, the Enigma actually managed to crack by Polish mathematician. Okay, Polish mathematician. So after the Polish mathematicians managed to crack the Enigma machine, okay, previously they don't have the plugboard. Then only the Germans, okay, add in the plugboard feature. After adding the plugboard feature, then they discover that they're no longer able to crack because it's become more complex. Then in the UK, okay, they after they since the Polish mathematician managed to crack the Enigma machine, okay, so they start to set up their own cipher bureau, okay, led by Alan Turing, okay, so which is the one in the movie, okay, Imitation Game. So and they managed to build the first computer in the world, Okay, so this is the picture of the first computer in the world. Okay, even for this after the World War II, Germans actually have no idea that their Enigma was cracked. Okay, then only after 70 years after World War II, okay, then only they released the secrets that they managed to win because they managed to crack the codes. Okay, crack the Enigma machine. Okay, back to mathematics. If we look at the cardboard setting itself, okay, earlier I say that the cable you can use 0 cable, 1 cable, 2 cable, up to 13 cable, because you only have 26 data. So there are many different possible settings that you can have here. So if we can take all into account, the cardboard is setting itself already have 15 figures here. 532985208200576. Okay, possible setting arrangement from that. So it will be very difficult for them to crack the crack the Enigma machine by brute force. By brute force here means you actually try out all combinations, because it's just too many. Okay, too many to do it within the day. So if they are unable to crack the message within the same day, okay, then the next day morning at 6 a.m. in the morning, they will change the key. Then everything will have to redo all the work all over again. Okay. Then the roto setting, okay, the roto setting, as I say, the roto itself, the setting, you have a 26 times 26 times 26, and you can have a different order from the 5, okay, together with the reflector of different arrangement. Okay, then so they ended up with this figure 3.28 times 10 to the 114. Okay, total possible setting. Okay, even for the computers today, I think you will need a few years to actually work out to try out all the combination if you want to do it by brute force. Okay. Theory versus practice. Okay, theoretically there are so many different settings that are available, but practically, okay, so the Germans only use 10 cables. Okay, so only 5 rotos. Okay, with selecting 3 out of 5. Okay, so in the initial setting remain the same. Okay. Then that they only use up to 1.07 times 10 to the 23 setting. Okay, so over here it says a statement state to test 10 to the power 23 key setting. 10,000 operators each checking one setting every second would take twice the age of the universe to break the code. Oh, okay, if you try out all the by brute force, of course with the help of computers now, okay, it may be possible. Okay, later on we will continue with this paper Enigma machine. This is to help you understand how the Enigma machine work. Okay, the paper Enigma machine, we actually have 2 versions. One with the sprinkle bottle. Okay, we actually can rotate it. Okay, another one is okay. So this is the file for the sprinkle bottle. We actually can cut and paste on the sprinkle bottle. Another type is the one that you can actually cut the roto here and pull on the number. Okay, you cut this part, here, and here, and you slot the roto inside 1, 2, 3, or you actually can change order if you want to. Okay, then from there we can actually see more on how to actually encrypt and decryptions of the messages from the Enigma machine. Okay, thank you very much. Now we will continue with doing the activity on how to actually run this paper Enigma machine, so that we actually can do the inclusions and the declusions. So as you can see from here, okay, this is the paper that I actually cut it into a few parts. So you can see like the first roto, the second roto, and the third roto over here. Okay, and I have the one that in the machine. Okay, of course it's been simplified as a paper form. So if you print out the paper, you actually can cut this place. Okay, you can cut here, you can cut here, you can cut open here, cut here, here, and here, so that you can actually slot the roto inside. Okay, you can actually slot the roto inside. Okay, let's say today we are going to encrypt the message. Okay, dot. Okay, let's say DOG. I want to decrypt the message dot. Okay, with the setting. Okay, let's say the setting AAA. Okay, this is the key that we're actually using, setting AAA. So what's going to happen is I'm going to place my roto, okay, to the three location inside my right side. Okay, so I'm going to set it as a setting A. Okay, this one, the second. Okay, the second roto I'm going to place it here. Okay, then the third roto I'm going to place it here. Okay, so as you can see, I'm going to place them properly according to my order of the AAA. So where is my AAA here? Okay, my AAA is this. Okay, with the setting A, and A. Okay, so of course I can set it into any order that I like. Okay, so for simplicity, for this exercise, I'm going to just set it as the letter AAA. Okay, so letter AAA. So now I'm going to encrypt the message DOG. So as you can see, I have the letter D over here. This is on the keyboard. This machine is actually running from this paper. It's actually running from right to left. So from the keyboard, go through the roto, the roto, second roto, and third roto, come out with reflector, and go through the first roto, second roto, third roto, and come out with output again. So, and the keyboard, according to my explanation earlier, once I press on the keyboard, the third roto will lift up by 1. Okay, will lift up by 1. So this is what's going to happen. So as you can see, okay, so as you can see, the third roto initially is at the setting AAA. Now because of press the keyboard, okay, it will lift up by 1 unit. Okay, so the D now, okay, will be we will start reading the value. What actually goes to the output of the D. So D will go to J, J will go to J, J goes to X. Okay, this X goes to X over here, go to R, R goes to R, go to B, the B will go to another B on the reflector, B here, then goes to this B, and goes to, where is the B? B is here, then goes to W, then W goes to W, goes to N, N goes to N, N goes to M. So the D will go to letter N. Okay, so next I'm going to press O. O. Let's see what's going to happen to O from the third roto. Okay, once I press the key, remember that the roto will lift up by 1. So initially it's B here, because I press the keyboard again, so it will lift up by 1. Okay, so if you have the paper print out as an actual hard copy, you actually can do it like pulling the roto, just like that. Okay, so let's see what will be the output of O. O goes to I goes to I goes to R goes to R over here, goes to U. Okay, where is the other U? U is over here, it comes to C. Okay, C goes to the reflector of the C, goes to the C. Okay, then comes to the C again, C over here, Y goes to Y, goes to X, okay, X goes to this X, goes to I. So the letter O will change into I, okay. Then what about the G? The G is over here, okay, the G is over here. So again, the rotor will lift up by 1 unit. Okay, let's see what's going to happen. Okay, so initially this is already at C. Okay, because you press the button, it will lift up by 1 unit. Okay, so this letter D here, it become D on your first row. Okay, so let's check on G. G, what is the character, the letter will goes into. So G will go to T. Okay, goes to this T, goes to Q, goes to Q, goes to X. Okay, X will goes to X over here, goes to J, go to the other J, goes to J. Okay, J will goes to this J over here, goes to Z. Okay, goes to Z, goes to V. Okay, V then followed by the V over here comes to I. So the G goes to I. So your recipients will actually receive the message MII. Okay, will receive the message MII. Of course, they actually have no idea what does it mean. Okay, so you must able to encrypt that again. So remember that the setting is actually important. We need to make sure that we have the same setting. Then only we can do the encryption. So let's see what happens if I reset the third rotor back to its original position. Okay. So remember the setting that we have earlier is AAA. Okay. So it's AAA. Here. Okay, so you can see A, and A. Okay, so I'm going to press the letter M. The M is over here. Okay, the M is over here. So what's going to happen to my third rotor? Again, it will lift up by 1 unit. Okay, it will lift up by 1 unit. So M, A will lift up by 1 unit. Here. Okay. So let's see what's going to happen to this letter M. So M goes to N, okay, N goes to N, N goes to W, W goes to the W over here, goes to B, B goes to this B, goes to B, okay, reflector goes to the other side of the B, goes to R, okay, R goes to R over here, goes to X. Okay, X goes to X, X goes to J, okay, J goes to J, come back to D. So the first letter works. D. Okay, what about the second letter I? Okay, the I is over here. The I is over here. So I'm going to press my keyboard, okay, the letter I on my keyboard. What's going to happen is my rotor will lift up again. So initially it's already here, B, because I press the button again, so it is lift up. Okay, so let's see what's going to happen to this letter I. So the letter I will go to X, will go to X. Okay, X will, let's see where is the other X. So X is over here, then goes to Y. Okay, goes to Y, goes to C, okay, goes to C, goes to the reflector C, go to the other C on the reflector, goes to U, goes to U, goes to R, okay, okay, R goes to R, goes to I, okay, then the I over here goes to O, so it comes back to O, okay, so the last I, okay, let's say I press the I again. So what is going to happen to my rotor? Again, it will lift up by 1 unit again. Okay, so initially you already have a position at C. So because I press the button, it goes up by D. Okay, go up by 1 unit D. So now I'm going to read the I again. So I here, I here. So I goes to V. Okay, V goes to V. V goes to Z. Z goes to other Z. Go to J. Okay, J goes to J over here. Goes to a reflector J. It goes to this J. Goes to X. Okay, X goes to X over here. Goes to Q. Goes to Q. Goes to T. Okay, where is the T? Where is the other T? The T is over here. Then comes to G. So we have successfully encrypted the message DOG into the encryptions MII. So you can actually send out the MII, okay, then to your recipients. The recipients actually can reset the setting AAA, then decode it into DOG again. Okay, so you are welcome to actually print out the file and cut it out just like how I actually explained earlier, and play along with its different settings. Okay, thank you very much.